Okay. So welcome to our second session of design, system design and coding. So I want to introduce a presenter today. So today's presenter will be Bineet. He's an engineering leader at Microsoft Azure. He will be sharing some of the interesting stuff today. And later, like if we have like 15 minutes in the end, I'll be going over a very exclusive, like a coding problem, and we'll be solving that problem and figuring out what's the right solution. It's a very interesting problem asked in one of the topmost FANG interview. It's not anywhere on the web, so we'll be covering that problem in the last 15 minutes. Over to you, Beneath.
Thank you very much, Sudhanshu. And I guess people are asking about the answers and winners, so that we'll probably do it towards the end, right?
Yes.
Okay, thank you. Cool. So, as the slide says, coding feeds system design, like Diljit Dosanjh's feeds here. People usually think of coding and system design as two different subjects, like you would consider computer architecture is a completely different subject from data structures and algorithms. But in this case, that's not true. It's not true in the case of computer architecture and data structure algorithms either. Both coding and system design actually go hand in hand with each other. And it's very important to understand when you're solving a coding question, there is no one right answer. Yes, there is an optimized algorithm, and it is good for the problem statement that has been asked for in the question. But if I change the problem statement a bit, the solution also needs to change, and that is something we're going to delve deeper into today. Just like in system design, when Pratul and Sudhanshu were explaining last time, to change one requirement, the entire design has to adapt to that requirement. And it is a better answer to be able to give a design upfront, which is adaptable to different requirements. However, that might not always be possible, and it's important to understand the design choices you are making upfront so that you know that if the question changes, how you're going to adapt your solution, go back to the drawing board, and make sense that in making this particular choice, this is the system behavior or the coding behavior that I'm going to result in. So, without much ado, we'll go through some of the basics of coding because for most of you, that is one of the top rounds that happens. One of the very easy yet difficult mechanisms people use is let's go through lead code. We'll do lead code easy, medium, hard, and we will be prepared for the coding interview. And for the most part, that's absolutely correct. Um, do keep mind the fundamentals though. Even when you're doing your lead code mediums and hards, understand why that particular choice was made of data structure of algorithm and why it was suitable to that particular problem, which means you have to have very strong fundamental knowledge on what different data structures are, what different algorithms are, what different concepts are. The most common coding questions that are asked in most FANG interviews surround these particular ones that I have on slide. Arrays, hash maps. Hash maps, in fact, any candidate over here would know hash maps are usually the answer to most coding questions that are asked. So yeah, in algorithms, how do you do different search in that solution space amongst concepts? These concepts are important to be able to perform those algorithms. You also need to know what is your time and space complexity. In my experience of interviewing a lot of candidates, many people actually don't get time and space complexity correct. And that's a big red flag, which means you don't understand the fundamentals of the algorithms you're building. So having said that, um, I think as we did with the system design problem, uh, there is an approach and an algorithm to solve a coding problem. Almost every time this algorithm will work. Given the problem statement, clarify what the requirements are. Once you have clarified the requirements, try to build the test cases because no matter how tough the problem is, your human mind is pretty intelligent. The moment you start writing test cases and thinking of all possible test cases like a test engineer, you will start understanding the pattern your mind is using to solve that problem. And then the only left remaining step is to convert what your mind is thinking into an algorithm, right? Sometimes it's difficult to understand what your mind is thinking. People have difficulty introspecting how they're thinking about the problem. So again, think brute force, Once you have considered brute force, more patterns start emerging, and you optimize your brute force algorithm to give the algorithm that the interviewer is probably looking for. Let's take a very simplistic problem. It probably cannot get more simpler than this. Given an array of integers, can I find out if the array contains a duplicate? Now, Siddhanshu, is it okay if we interact with the audience, or do we want to keep it just one way?
Up to you.
Okay. So for this question, just anyone, can you raise your hands as to what a simplistic solution for this problem is? Finding duplicates in an array. Okay. I'm going to choose from the raised hands. Nirbhay, just I will choose who gets to answer. I think Nirbhay went first. Nirbhay, can you unmute and answer?
Hello. Yes, sure, sir. Sir, can we use here hash set? Like just traversing the array, we would be putting our numbers in the hash set, and if the number repeats itself, like it's already present in hash set, then it's contain duplicate.
Okay, that's a good optimal answer. But if you go by the algorithm of what is the brute force, what is the brute force algorithm over here?
So for brute force, what we can do is we could take hash map and we can store the frequency of the numbers, and if any of the values having frequency more than one, then it contains duplicate.
You're still thinking of an optimal algorithm. I've just given you, I give you a row of people, and you have to find if anybody is
Okay.
a twin in that. Would you
Okay, sir.
put people into hash map? No, right?
No, sir. Also, what we can do is we can traverse the, like we could take first element and then again take, take a nested loop from I plus one till end and check like is it present or not. If it is present, then we can say it contain duplicate.
Excellent.
Like it would
So
take off and square.
yes, and that is your uh, brute force algorithm. As you correctly pointed out, it's going to take O of n square. What is the space complexity of that algorithm?
So for that algorithm, time complexity would be of one
Space
because we are
complexity
not
would be O
taking.
of complexity. Yeah. Time complexity O of n square. Space complexity is O of 1. Excellent. Thanks. You can put your hands down.
Thank you, sir.
Thanks, Nirbhay, for answering. And as Nirbhay correctly pointed out, so this is the algorithm for the brute force. Uh, Always think brute force. I know the mind jumps into going for the optimal algorithm, but there is a big saying in software engineering, and it's true for coding questions as well. Never pre-optimize. You don't know, in thinking of the optimal algorithm, you are missing out on the nature of the problem, the essence of the problem that you're trying to solve. So always first go for brute force, even if it feels stupid, and then put your insights into how it can be better immediately. Okay. So what Nirbhay was mentioning was, let's have a hash set, and if I see a number show up in the hash set once, I'm gonna return true that yes, I have a duplicate. I just escape out of the loop. Nirbhay was also mentioning an example where he can keep the frequency of the number if my question is slightly different, where if I have more than two duplicates or the number is duplicated more than once, only then return true. So you can have more granularity in your algorithm if you have a frequency map instead of just a basic hash map with a Boolean value. This is an even more optimized way of doing it because it uses some of the language's existing properties to create a set, and you can assume that the language has put in enough optimization within the set concept to be able to calculate the set as optimally as possible given the hardware architecture. And you just compare, if my set of unique elements in the array is less in size than the entire array size, then of course I must have had a duplicate, right? If you give this answer to an interviewer, they might be impressed, but it doesn't answer the question that they're asking to you. So keep this as a last resort of just being flashy and showy that, I know an even smarter way to do it. Okay. Now, this was a very simple question. Can we make it more difficult, more interesting? As we went through, what is the time and space complexity? We talked about O of n square for the brute force, and hash map. Again, I know most of you probably would know hash map is going to be O of n. But then for hash map, in the worst case, my space complexity is also going to be O of n, right? Which comes to the second question. What if space complexity is a concern? Can we do this in place? So again, raise your hands of who can answer that question. Sure, Lalit, go for it.
So if we are using hashmap, then we have to tell that what is the time and space complexity, right?
No, if space complexity is a concern, like if I'm using a hash map, in the worst case, my space complexity is going to be O of n, because I'll have to, if I don't have any duplicates, I'm going to have to create an entry for each and every element in the array.
Yeah, sure. So all the elements we have to insert in the hashmap. So the space complexity would be OL.
Yes. And what if I don't have that kind of space? I want to be able to do it in place. How do I do that? I also don't want to do O of n square, because yes, that gives me O of 1, but then n square is bad.
Then in that case, we can do like if we have positive integers, then we can map the indices in the array. In this way, we are not using any extra space, just we are modifying the current array. Let's say we have positive integers, so we are using indexes of the array to mark that is it present or not. But this solution works only for positive integers.
Exactly. And going back to the original algorithm, you should have asked me, do you have a range limit on the integers? I have not told
Yes,
you that there's a list range limit, right?
yes,
So
it should
my
be clear.
yes. So my question is, my answer is there are no range limits.
Okay. Yes, if we can sort the array, then we are not using any extra space, and then we can compare adjacent elements because the same number elements will occur adjacent. Then we can just check previous number. If that number occurs, then we can say it is duplicate. Otherwise, all the unique entries will be an array if we have no duplicate entries.
Great.
So in this
So
case, the time complexity would be of n log n and space complexity is O1.
excellent. Time is O n log n, space complete O of 1. I agree that the asymptotic big O complexity is big O of n log n. Can we be slightly smarter about it? Like in your
Uh,
solution, I'll have to sort the entire array. Then I have to go through the entire array. Maybe in the worst case, say my duplicates are at the end, I'll have to go through entire array and then find out whether a duplicate is there. So O of n log n plus O of n, right?
yes.
So can I be smarter than that?
So we have to process all the elements, right?
Hmm.
So if we have multiple occurrences, like if we have 5 occurrences of one, but just we need only 2 occurrences of one to predict that is there any duplicate element or not.
Hmm.
So we can use.
Let me give a prompt. How would you do the sorting? Which sorting algorithm will you use?
We can use merge sort,
Okay.
which are the most optimized one.
So if you use merge sort, what do you do in a merge sort?
Merge sort is basically works on divide and conquer strategy. We first divide the array into 2 parts. We first sort the first part and then sort second part and then merge both these parts. So
When you're merging, will you be able to find out if you're finding duplicates? Because when you've
yes,
broken it down into two, eventually, at some point, you can keep track that I am encountering this element twice.
yes. Like when I'm merging two arrays, then I can check that if that element occur in two different part in both the partitions or not. So in that way,
Exactly.
we can also check that is that element occurring to.
So you have eliminated O of n in that entire algorithm as well. Within
Yes,
n log n, you can do the entire sorting. If you use the same thing for quick sort as well, same solution applies. Quicksort, you have to ultimately merge it, and at that point of merging, you know whether a duplicate has been encountered or not. Right?
Yes, yes, yes.
Cool. Cool. Thanks, Lilith.
Thank you
So
so much.
yeah, so that's how you can think about problems more creatively. I think we sort of touched upon if you're okay with k duplicates, but should alert only if there are more than k duplicates. So how would you go about that? I think one solution that was mentioned by Nirbhay was, can we maintain a frequency map where I know how many times I've encountered this duplicate? If I go back to Lalit's answer, even in my merging algorithm, I can do something very similar if space is a concern, right? Um, One other aspect that you guys very nicely touched upon, do I have constraints on the value range of integers? So positive integers is obviously one case that you guys talked about. What if I told you that the integers are only going to be between 1 and 10? So obviously, if my array size is greater than 10, I must have had a duplicate, right? So that's a very easy way to be able to just escape out of the algorithm. If my array size is greater than my range limit, then I must have a duplicate. Within O1, I can find that solution. And if not, then I go through these additional ways to do it. One of the examples being the what do you call it? The range thing. Once you have a range applied, let's go back to the sorting algorithm. Even the sorting algorithm, you can use something like bucket sort or radix sort and be able to find out the uh, duplicates in O of n time, right? So you can see in putting constraints, I can reduce my worst case time complexity to O of n while still keeping my space complexity very minimal. Okay. Fifth variation. What if the data is coming in a streaming format? How does that change the solution? Anybody want to volunteer? Oh, by the way, Pratul is right about the merge sort additional space. Yeah. um, but any volunteers for streaming arrays of integers and trying to find duplicates, especially when I think there's a monotonic property that the integers are always expected to increase in size. Can we do that better? Sure, let's go for it.
So like in streaming that there is mentioned that monotonic property. So if our data is increasing, then there is no need to maintain the record of previous numbers. Like data is increased, so we can ignore just previous numbers, that we can concentrate on current upcoming numbers. So in that case, we can reduce our space, because if let's say our number is increasing, so that we can pop out previous elements that we know that it is not going to come in future. So, but we have to know that some trend in the data, like how much larger data is coming, so that we can create a certain type of window.
So if you're working for a very big tech company, what do you think the solution here is going to evolve to? Because I can tell you that at this point, we'll start putting models into place. Can I estimate the frequency? I keep a frequency of what numbers I've encountered so far, and I start estimating and predicting whether I'm going to find a duplicate in the next five entries that come in. And in doing that, presumably this entire code is being written to solve a business problem. In doing that, I can solve the business problem even more efficiently. Again, I'm not giving the exact variation where that's going to look like, but be aware that these are different variations that I can put in where I can take this extremely simple problem, convert it into a business problem, and then you start thinking about system design for that business problem. Okay. So one thing I've written over here is, how about different data types? So what if it's not integers? What if it are floating point numbers? What if it's string? What if it is some complex data structure? Try to reconsider all of that we have talked about till now. Does that still hold in those cases? Can I still do that kind of say a sorting algorithm? Would it be efficient? If I'm doing a O of n square comparison, is it going to be efficient? Think about all those different problems in your head, how that solution changes, and if you have questions, definitely ask. The last one, what if the array of integers or different data types that we have been provided in the question don't fit into a single machine? How does this algorithm change? Because now keeping a hash map is going to be a distributed hash map, a distributed hash table. Can we do better than that? Or even doing a distributed hash table, do we understand how that distributed hash table needs to be implemented? So again, you have to think about how does the data stay in different machines, where if there's a duplicate between the first machine and the last machine, you will still be able to find that in short time. Some of the very obvious algorithms can come up is I can do a map and reduce on that particular data set, and that's a great one. But within map and reduce, can I be even smarter? Can I have some other, if I know some properties of the elements, can I have a better way, even while distributing that particular array, to find if they're duplicates, right? Cool. So I think I've gone through a lot of variations over here, but the point is understand how system design changes on the basis of it. After this, I'm going to just speak about this quiz question, but I'll let folks answer about that later on, just like with the last time. I'll just speak to what I expect in this particular answer. The question is again pretty simple. Given an array of n integers, find the maximum product of any k equal to 3 integers in this array. For this quiz question, what I expect is a subjective type answer, where these questions that I've asked over here, you want to answer all of them and you want to be able to say why that particular choice is better, right? Think about it later and we'll come to it. I'll go to another particular favorite problem of mine, which you probably wouldn't have experienced any time in any of your interviews. And the reason for that, it's a very exclusive problem that happens in production within our systems. Okay. We're trying to build a health monitoring system where each of the n entities or machines that you're monitoring can have k health signals. Each health signal can either be up, down, or empty at any time point. I want you to build a time series database to store all these signals. Eventually, we want to implement the method, is machine healthy, with your own design choices. And some of the basic structures that I'm going to give is you have an enum called health determination, healthy or faulty. And then you have a class single health observation, which contains the signal name, the time of observation, and the health determination. Okay, what you need to build is a system that can collect all this information, process that information in real time, and then give an answer as to whether the machine is healthy or not. As you can imagine, there are a lot of the variables that I have not talked about over here. What is the frequency of emission? What is the kind of database that I want to store it in? What is the data structure of the component that I'm going to store? The object that I'm going to store? How do I do different kinds of operations depending on my data structure choice? How can I do different kinds of operations on that particular um, object or a time series of objects? For example, if I'm talking about is machine healthy, presumably it'll be like, okay, if I'm getting k health signals from the machine, then let's say we are getting 100 health signals from the machine. I'm going to say if at least 10 out of 100 health signals are unhealthy, I'm going to consider the machine as unhealthy. Cool. That seems like a good start. What do you mean by a signal being unhealthy? That's a difficult question. So I'm going to say if in the last 10 observations of the signal, I see at least 5 observations are faulty or empty, then I'm going to consider the signal as unhealthy. Okay, that seems like a good choice. Now, how are you going to do the, like, now it comes to data structure. If I'm going to see at raw time signals, so let's go to this thing. If you visualize the entire problem, you basically have 3 states. You have no observation. The x-axis over here is time. Y-axis is no observation, faulty, healthy. So for a typical machine, for two different signals, you might see, okay, it's healthy, 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 healthy. Imagine this is each time point. And then suddenly it becomes faulty, 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 faulty. And then suddenly at some point it becomes healthy again. Over here, another health signal started off faulty and then goes to healthy. And you'll notice that at a corresponding time after the signal 1 went faulty, this guy just went empty completely. Empty, empty, empty. And after a small time, after this went healthy again, this became healthy. Now to be able to process, I won't again give the data structure or the algorithm right away. That is again exercise to you. And if this is something people want to delve deeper into, we'll have another session just talking about the coding exercise that goes into this. Basically, you want to find out if this particular period, can you guys see my cursor though? Ashidanshu, can you guys see the cursor?
Yes, yes.
Yeah, because I'm doing it in Google presentation. I'm not sure if I can use any of their cursor mechanisms. Okay. So this particular section, if this is greater than a particular threshold, so say my threshold is, if the time period from this to this is 12 minutes and my threshold for faulty is only 5 minutes. So that means at this 5-minute period, I'm going to start saying that this signal is faulty, right? So one algorithm to do it is, I go through my entire list or queue of health signals. Anytime it goes faulty, my counter starts. I keep counting, 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 counting until I reach, oh, I have reached the number of count level that corresponds to 5 minutes. So at this point, I'm going to raise this signal 1 is faulty. Over here, similarly 5 minutes, but this is 3 minutes. So my counter started over here, and then 3 minutes it went to healthy. My counter stopped. So it is not faulty until this point. Then I come over here, come over here, come over here. Oops, I don't have any messages anymore. Now my threshold for faulty was 5 minutes, but my threshold for not getting a signal is 10 minutes. So, and again, I said this is probably all of, if this is 12 minutes, then this is around 13 minutes. So I start over here. I start a different counter, which is not faulty. I'm not seeing any signal, not seeing, not seeing, not seeing, not seeing, not seeing. At this point, oops, for 10 minutes, I'm not seeing a signal. So now this signal is faulty as well. And maybe my threshold is 2 signals being faulty on the machine means the machine is faulty. So this signal went faulty over here. This signal went faulty over here. At this point, I'm going to start crying that the machine is faulty. Now, what if my threshold was such that maybe the threshold was 12 minutes? So at this point, signal B or signal 2 is going to get faulty at this point. But at that point, already signal A has become healthy. So I need to keep tracking what is the current health of each signal. And then my solution has to consume that and say that any point, I'll keep a moving sliding window over here. At any point, if it becomes faulty, I am going to um, tell that the machine is faulty. Okay, so to do this, as we went over here, my data structure can be, since I have single health observation, I can have a list of health observations, and always I go through, just like with the array problem we had earlier, I go O of n through streaming data of this array, and then I start keeping these counters or keeping maybe a small data structure that determines whether it's healthy or faulty at every new observation coming in. Can we be smarter than that? And this is how I'm saying it turns into a system design problem, where if I'm going to be smarter than that, I need to store it in a more efficient manner. And what do we see in this particular graph? For all these timestamps, so say all these times are coming once every second. Storing that much raw signals is too much load on the database, and your time processing will also be very time taking. So instead of storing this entire period where it is healthy or entire period where it is faulty, can I store only the deltas? So at this point, I know it went from faulty to healthy, which means for every point before that till my starting observation, it must have been faulty. So I can have a new data structure that says current health, old health, current health determination, old health determination, last seen time, and current seen time, right? So I can get the entire information of how much period it spent in this faulty state and how much period it has spent in this healthy state so far. So if I'm taking over here, I'll see that my current determination is healthy, old determination was faulty. I've spent uh, 2 minutes in healthy, and previous to that, I had spent 5 minutes in faulty. Okay. I come over here, I can go to empty. Or if I come over here, I can go to faulty again. So same thing. I maintain only the deltas of where my signal is changing. In doing that, I have these pre-cooked things and pre-cooked objects that can help in my calculation of no matter what threshold I put. If tomorrow I change the threshold to say that instead of 5 minutes, I'm going to wait for faulty of 7 minutes or faulty of 8 minutes, I don't need to go and change the algorithm directly. I can only look at these deltas from if my delta size is greater than 7 minutes for a faulty case, immediately just spit out that it must have been faulty. There is no other option, right? Now, just like with the coding questions, there are many variations. We first talk about what a data structure looks like. What is the expected read-write QPS? What is the storage size estimations? What would a reasonable algorithm be to determine a health regression? How to verify data integrity, deal with data corruption? How to ensure availability for the data pipeline and storage solution, which goes to why do I miss signals? Because because the machine is bad, or it could also be that my pipeline is bad, which means that I'll probably miss all signals. So can I have an additional check in my data system to say that not only this signal has lost heartbeat, but all signals have lost heartbeat, which means something is wrong with my system and not with the machine itself. So in that case, I should say the machine is not unhealthy. A machine is healthy, or machine is probably healthy. My system is unhealthy. So you go through again those edge cases, and again you have to always think about authentication, authorization, and encryption at rest for that particular system where you're passing this data. Whatever middle of man in the middle attack happens, and it's able to get data about the machine, and any bad actor can know which machines are bad and try to uh, get into those machines because it's probably not working properly, right? Because we are probably not monitoring it, not scrutinizing it. We don't have control over the machine. They can have some way to access the machine and be able to get customer data out of it. So we have to think about those aspects as well. Cool. So Siddhanshu, that was about the most of what I want to talk about. I'll give probably 5 minutes for question answers about this question or the previous question, and then Siddhanshu, you can take over for your topic.
Sounds good. Yeah.
Any question answers?
Go ahead, Raj.
Yeah, so when you say that the streaming data is there, does that mean like it's the data is coming on a network or like uh, it's in place stored, but we are considering it as a streamed data?
Very good question. Um, it's a good question to clarify with the interviewer. In many cases, it can be considered as in-place data. It's just that you're reading it in a streaming fashion like a memory stream. In the example that I was giving, it is more like it's coming over the network. It's to getting stored in a queue in my network interface card, and then I'm reading from the queue on the network interface card in real time, maybe from my kernel, from a user mode driver, and then trying to find out whether uh, whatever my operation is.
Okay,
But
understood. Thank you.
good question. Like it could be reading from, say, in the cases where it doesn't fit in a file that can fit into the RAM of a single machine. Then maybe a solution is I just parallelly read from the file distributed across many machines, and then in my merging of the or in a reading of the file, I'm able to merge and find out whether there are duplicates in the arrays of the files that I'm reading. Okay.
Okay, understood. Thank you.
I think I had more hands up. Any more questions? Okay. Then I would be interested in learning if you didn't have questions about the health monitoring system. I'll be interested in knowing that how you figured it out, because it's not an easy system to figure out. Just to give you an example, within Microsoft, we ran with the brute force system for about a year before we had to decide to go to the optimized system where we talk about these deltas. So there again, lots of considerations that need to happen when you're working in a corporate structure as to the amount of effort that goes into it and how you build those particular systems. But ultimately, um, most of systems at big tech tend towards an optimal solution because we want to be able to save money, we want to be able to create the best experience possible for our customers, and be smart in doing all of that. So I think, yeah, folks. Oh, now I have more questions. Lalit, go for it.
I just want some more clarification on this question. Like, uh, we can have K health signals. So what does it mean? Like, we only have K health signal, or it is coming in a streaming format? And the second question is, let's say a machine moves from healthy state to faulty state. So can we have a query at a specific time so that we can check that machine is healthy or unhealthy at that specific time? And if let's say machine comes from faulty state to healthy state, so that we can have a reason that we if you want to know that what would be the reason that machine is faulty at that time and now that it is healthy. So
All great questions. So let's go with the first one. First one was, is it coming in a streaming fashion? It's always a good question to clarify, but think about it yourself, because your maturity as an interviewee shows in asking about that particular question. What was my statement about the health monitoring system? That I've got machines and I've got health signals on those machines. So presumably there is some agent running on the machine that's calculating these health signals and sending it to me as a control plane server, right? So by nature, what does that become? It becomes sort of streaming, because I don't know beforehand how many observations I'm going to see in the future. I only know that these pieces of data are coming to me at a particular frequency and I need to keep processing them in real time. So by nature, they become streaming data, right? Now, second question was when the machine becomes healthy or too faulty, faulty to healthy. By the way, the graphs that I was showing was the graph for a health signal, not for the machine itself. But taking the question as it is, after I've superimposed all these graphs on top of each other and I'm able to determine whether a machine is healthy or faulty, yes, I would want to have some queries to be able to find out at what point did the machine go unhealthy, what was the reason the machine went unhealthy. Who's unmuted? Okay, Deepak, thanks. So at what point the machine went unhealthy, and the data structure that I was mentioning about the delta gives you that answer very nicely, because no matter at what point I'm asking, I can actually ask this system, the system that I've designed, I can ask the question at time point t1, what was the health of the system and how long was it healthy or unhealthy for. It will only go back and see what are my time delta or my health deltas before that time point and give you the entire story of what happened. You can almost think of it like your Facebook timeline feed. You can say from January 1st, 2021, before that, what is my feed? What does my timeline look like? You can go to that point and you'll be able to see exactly what has changed from that point onwards, right? So I hope that answers your question, Lalit.
yeah, sure.
Yeah.
Thank you.
Raj?
Yeah, so for health monitoring system, so like when we talk about encryption at rest and in transit, so as per my understanding, when we are in cloud, so like let's say for RDS, we are a button click away to encrypt the whole database. Now I wanted to know, like, is there anything more to discuss in this with the interviewer, like for encryption? Because I think we don't do anything other than like asking RDS to encrypt the database. And in transit, like SSL handles the encryption. So what's there to talk about in encryption part?
Those are exactly the ones. Again, these things that you say are obvious. If it's a system design question and you're not bringing those questions up, then it doesn't seem as obvious, right? So if say for an RDS, you can encrypt the entire database. What should be like, ultimately, I want to be able to make a health determination on the machine. And I need to do it in real time with minimal lag as possible. Is it a good design choice to encrypt the entire database? And when I'm getting asked that question, whether the machine is healthy or not, I first spend a few seconds trying to unencrypt, even if it's milliseconds, few milliseconds to unencrypt all the data points that I have in the system, calculate on top of it, re-encrypt it, and give the answer. That's probably not a good choice. So that's where the discussion will go into. What are my constraints over there? Do I really need to make sure that it needs to be completely encrypted? Even in my encryption algorithm, can I have some sort of metadata to be still able to determine healthy or faulty in a smarter way? It goes in that direction, basically, to your question.
Okay, understood.
Yeah, thanks. I think we are at 46. So, Siddhanshu, I want to give enough time for you to go through your item.
Yes, I think we'll first go over the answers for the last session's quiz because folks are interested, and we'll announce the winner. And after that, I'll share an interesting coding problem, which you guys can attempt offline. I'll share the requirements and code fragment, and we'll discuss the solution in the next class in the interest of time. So I'm going to share my screen. Is my screen visible now?
Yes, Siddhanshu, it's visible.
Okay, so our first question was, why is the read availability more important than write availability? Read availability means that rendering song recommendation on the app is more important than recording the song listening data points in the backend. The correct answer is B. Read availability highly impacts the customer experience, while write availability issues will have less impact on the customer experience. Because if you open the app, you don't see recommendation, that's a terrible experience, right? Second was, which approach will be most suitable for application servers acting as producer to send the data or message at the backend, right, to Kafka for async processing. Like you listen to song as at time t, right? There was a close call between B and C, but the correct answer is C, because if you create thread for each of the message you're receiving, you might have a bottleneck in terms of number of threads you're creating in your machine, right? And your machine might uh, behave incorrectly, right? It might crash, it might have issues, right? So it's always better to log it, and then, there will be a process that will read the log and send it to Kafka. And we need eventual consistency. We don't need strong consistency. So this is fine. Next is, which broker technology will be suitable? Correct answer is C. You can use Apache Kafka, you can use Kinesis or Confluent, which is enterprise Kafka. Either of them works. Why did we choose to use app server ID instead of user ID as a partition key for Kafka? Because it leads to lesser connections between app servers and Kafka partitions. Correct answer is D. Why did we prefer NoSQL over SQL? Correct answer is C. NoSQL can handle high data velocity better, and transactions are not required in the system. How are we avoiding hot partitioning problem in the AWS DynamoDB? I know we didn't cover this, how we are preventing, because we wanted to cover through quiz, but we'll deep dive more maybe in the next design session. By using the right partitioning key based upon user ID/day, which will create fairly uniform partitions, right? Which means that every partition will be utilized uniformly. There will be no partition which will, like, one partition is overutilized, other is not getting utilized. So given that we know that on an average, a user listens 15 songs a day, so every partition will be fairly utilized. Next is, which of the following lead to higher accuracy in song recommendations per user? Like, for example, top 10 songs based on the last 7 days listening data. Correct answer is B, right? So think of like a song maybe at, stack rank, maybe 11 or 12 for 3-4 days, right? But later on, for the remaining like 6 days, it is at rank 7, right? But if you include the data points, of that song when it was at rank 11, 12, beyond 10, the overall rank of that song might be influenced, might have gone upper by 7, right? Maybe it's 5th, right? So it's always good to, take a little bit more data to make sure the accuracy is higher. So the correct answer is B, taking top 15 songs per user per day for the last 7 days, and then finding top 10 songs overall. Next is, which of the following is true for LSI? All of the above is true, basically. LSI has same primary